My name is Pavitram, and today we are going to reveal some mysteries of the fourth dimension. But before we start, we need to know what a dimension is. A dimension is similar to a direction. A line is one-dimensional. If we extend this line, then we get a square. Extending that square gives us a cube with length, width, and height, 3 dimensions, the world we are familiar with. But what if I tell you that there is the fourth dimension and we cannot see it? I will talk about this fourth dimension today. But remember, time is a temporal dimension. Today I will be talking about the fourth spatial dimension. Now that we know what a dimension is, let's talk about the 3 main concepts, each with a problem and scenario related to it. My first problem is that imagine you're starving. On the kitchen table, you see a jar of cookies. You're so tempted to open it, but the jar cannot open. You try harder and harder until your face turns red, but you simply cannot get the sealed cookie. How do you get the cookie out of a jar without opening it, using the fourth dimension? My second problem is that you wake up on Monday morning and find out that school starts in just 5 minutes. After brushing your teeth like this, you run to school. So how can we prevent this problem? How can we control time? And my third problem is related to transportation. How can you travel faster between 2 destinations without generating more energy, using the fourth dimension? My hypothesis for the first cookie problem was that if a cookie was trapped inside a jar, then it would be impossible to separate the cookie through the fourth dimension because the cookie is sealed from all 6 directions. My hypothesis to the second problem is about general relativity, my background research. General relativity is a way to understand gravity, and it was proposed by Albert Einstein. Einstein imagines a net, which consists of space and time. When objects like the Earth are added on the net, space and time curves. This curvature is what causes gravity. If you draw 2 points on the Earth's equator and continue going forward, then eventually the 2 lines will meet. These straight lines on a curved path are called geodesics. The 2 lines might think that a force led them to the top of the globe, but it was actually due to the curvature of the globe. Similarly, gravity is not a force. It is occurred due to the curvature of space and time near massive objects in our geodesical paths. The idea that space is curved was proven in 1919, where even light bended near masses like the sun. But along with space, time is also curved. Velocity is speed in direction. It's a vector quantity, and the difference in velocity is known as acceleration. According to a concept called time dilation, the greater the acceleration, the slower the time you experience. According to this formula, every object curving space-time is already accelerating, which means time is slower near objects which curve space and time. This effect is not noticeable on Earth, but it is with objects with plenty of mass, like black holes. Black holes curve space and time so much that time is practically frozen. 1 second on a black hole would equal to thousands of years on Earth. So if you went to a black hole, experienced 1 second, and came back, then thousands of years would have passed in just 1 second. That is why I say that time travel could be possible. Now coming back to my hypothesis, I hypothesized that if you go near massive objects, such as a black hole, then you can slow down time and move through time at your own will, because the proven theory of general relativity supports this fact. My hypothesis for the third problem is, if I tried to travel in the fourth dimension, then I can travel quicker without using more energy because it might provide a shortcut, which is hidden from the normal 3 dimensions. Now let's jump onto the first cookie problem. It's quite frustrating to solve this problem because we can't visualize the fourth dimension. That is where Flatland comes in. It's a novella written in 1884 by Edwin Abbott. Edwin imagines a 2D flatland inhabited by 2D flatlander. Imagine this is Flatland, and this blue guy over here is the flatlander. The flatlander can move north, east, south, and west. But it cannot move upwards. We can imagine the 3D cookie scenario on a 2D flatland. In Flatland, this is the flat jar, and this is the flat cookie. For some reason, the flatlander fails to open the jar from the top. This is similar to our scenario. According to the flatlander, you can't take the cookie out because it is trapped from all 4 2D directions. But in the third dimension, 3D humans like us can transport the cookie upwards in the third dimension and place it outside of the jar. According to the Flatlander's perspective, the cookie disappeared from the jar and appeared outside out of nowhere. The same would happen if we transported the cookie to the fourth dimension. We would perceive it to disappear and appear outside of the jar, out of nowhere. Now let's time travel to the second scenario. According to general relativity, you can go to the future in different speeds, but you can't go to the past. Time always leads forwards, not backwards. This phenomenon is known as the arrow of time. The arrow of time is caused due to the second law of thermodynamics, entropy. Wheat can turn into bread, but bread cannot turn back into wheat. This disorderliness is caused due to entropy. It just so happens that in our universe entropy increases, which is why time goes forwards. However, studies show that in extra dimensions, entropy is constant. Constant entropy is known as an isentropic process, in which any process can be reversible. If you drop salt in water, then you can perform the exact opposite in the fourth spatial dimension. You can also go to the future at your own will. I have a Rubik's Cube, and there are 6 possible outcomes for which color it will land on when I throw it. It turns out that I got green. So why didn't I get any other color? Well, Hugh Everett, who proposed multiverse theory, says that in other universes I got different colors. But it was previously determined by the universe I live in right now that I must get a green color. Because we live in 3 dimensions, we cannot perceive the other outcomes. But in the fourth dimension, we can. Basically, I can customize my future. So if I'm late for school, then I can change my upcoming future or reverse time and sleep in. Yay! Now, let's sprint to the third and last problem, towards Flatland. Let's envision transportation on Flatland. Imagine that this is Billy's house, and this is Bob's house. These houses are located on opposite sides of the planet. They're known as antipodes. Now imagine Billy wants to go to Bob's house. So he will go up to the clouds and travel to Bob's place. This is what normal planes do. Now let's curve 2D Flatland into a 3D cylinder. The distance between the 2 houses is significantly reduced, so more energy is not required for transportation. By curving 2D Flatland into a 3D shape, we can travel faster. So the same could occur if our 3D world was curved around a 4D donut or hypertorus. An accidental study performed in 2015 supported that our universe might be shaped like a hypertorus. So what happened in our Flatland demonstration could be true with the whole universe. If the concept was applied to Earth, then the fuel requirements for planes would decrease because they would have to cover only tiny distances. This would reduce global warming because in 2018, 2.4% of the global warming was caused due to plane pollution. In conclusion, for the first problem, I was incorrect due to the lack of perspective and visualization. For the second problem, I was also incorrect because I did not consider going past through time as well. And for the last problem, I was partially correct because the fourth dimension does allow a shortcut, but I was uninformed about the specific process. But wait, is there the fourth dimension? And if it does exist, then what are some ways to study it? To answer that question, I think I need to turn on the news channel. Dimensional News, a news channel where the confluence of research and experiments flows as we present updates of the fourth dimension studies. Today, we would like to talk about the clues of extra dimensions. Imagine you have an electrical circuit where electrons move from a negative to a positive charge. Now, if you place 2 magnets perpendicular to the circuit, then the electrons are deviated through the Lorentz force, and electrons are stuck in a 2D system. This process is known as the quantum Hall effect. An experiment was conducted in Europe and the United States on January 2018, where the quantum Hall effect was demonstrated in the fourth dimension. For example, in the European experiment, rubidium was cooled to absolute zero. The atoms were trapped inside a lattice of lasers, and a charge pump was created. The certain movements in the charge pump depicted how the quantum Hall effect would work in the fourth dimension. 3D atoms showed how 4D atoms would work. 3D cubes cast a 2D shadow. Similarly, 4D objects can cast a 3D shadow. This experiment was like studying those shadows. By studying these 3D shadows, we can understand, then connect, and at last communicate with the fourth dimension. This communication will help us to implement those 3 scenarios. The research is ongoing, so stay tuned until next time we meet you on Dimensional News. So the next time someone tells you, who cares about the fourth dimension? It won't impact my life. At that time tell them that no, the fourth dimension will impact your life. By 1, getting a cookie out of a jar without destroying the jar. 2, controlling time. And 3, covering long distances in short periods of time by curving ourselves around a hypertorus.